Assalamu alaikum students. In lecture number 23 we discussed one-way analysis of variance. In today's video we shall discuss two-way analysis of variance, and this is the part 1 of two-way analysis of variance series. Two-way analysis of variance is a statistical method used to analyze the influence of two categorical independent variables, which are also called factors, on a quantitative dependent variable. Each independent variable has two or more levels, or you can call them groups. For example, the variable of gender might have two groups or two levels, male and female. So you can have different levels and different groups. So ANOVA allows us to determine if there is a significant interaction between the two independent variables and how each factor independently affects the dependent variable. In other words, it helps to understand how different combinations of the two factors impact the outcome. Remember, this is two-way analysis of variance. Why it is two-way? Because there are two independent variables which are categorical in nature, and we use this test when we expect an interaction in our study. Literature review guides us to deduce that these two categorical variables might have an interaction to affect the dependent variable. The significant effect of each independent variable separately on the dependent variable is called the main effect. And an interaction effect occurs when a combination of different groups of independent variables shows a significant change in the dependent variable. When to use two-way analysis of variance? You can use two-way analysis of variance when you want to know how two independent variables in combination affect a dependent variable. For example, you could use two-way analysis of variance in the situations given below. The effect of gender and age on the risk of developing a certain disease. Or a marketing manager wants to know if the type of advertisement, print versus online. This type of advertisement is independent categorical variable. We call it factor, and print and online are the levels of this factor. And target audience, male versus female, have an effect on the brand awareness. So brand awareness is our dependent variable. Take another example. A human resource manager wants to know if the type of training on the job versus classroom and the length of training 1 day versus 2 days have an effect on employee productivity. Or another example, a product manager wants to know if the type of product, new versus existing, and the price of the product, low versus high, have an effect on the sales. So you can see there are two categorical variables with varying groups or levels affecting the dependent variable. Assumptions of two-way ANOVA are similar to one-way ANOVA. Level of measurement: the dependent variable should be measured at the interval or ratio level. It should be random sampling. Independent observations should be there. No observation should be dependent on the other observation. Normal distribution: the dependent variable must be normally distributed across the groups. Homogeneity of variance: the samples should be taken from populations having equal variances. This means that variability of scores for each of the group is similar. So to test this, SPSS performs Levene's test, which is part of the output of the ANOVA statistical analysis in SPSS. And when we develop hypothesis, if we are talking about strictly in the statistical terms, test for the differences between the level of factor A. For example, you got factor A and factor B. So the means H0 is the means of the levels of the factor A are equal, and H1 would be at least two means differ. Test for the factor B would be the hypothesis, null hypothesis, the means of the levels of the factor B are equal, at least two means differ would be the alternative hypothesis. And test for interaction between factor A and factor B. H0 would be factor A and B do not interact to affect the mean responses, and H1 would be factors A and B do interact to affect the mean responses of the dependent variable. So two-way ANOVA, as I told you, it has three distinct hypotheses for main differences in the level of the first factor. For example, gender in the coming example which I am going to solve for you. Mean differences in the level of second factor, position in this example. Any other mean differences that may result from unique combination of the two factors, gender and position. So first two hypotheses are called main effects, and the third hypothesis is for interaction. Our example is, the research question shows what is the impact of position and gender on stress. Does gender moderate the relationship between position and stress? Let's do it using SPSS. We have an SPSS file named ANOVA. From the menu, go to Analyze, General Linear Model, Univariate. This will open this dialog box. Take your dependent variable to the dependent variable box and your independent categorical variables to fixed factor box. Then we go to options, go for descriptive statistics, estimates of effect size and homogeneity of the variance test, then OK, and then we go to post hoc. Here you can see there are two variables, one is position and other is gender. Go for that particular variable which has got more than two levels. So position has got three levels, so we move this particular variable to the post hoc test and we just use Tucky for the multiple comparisons. Continue and OK. So the output shows us that what is the number of senior managers, middle managers and junior managers. This is 60. And what is the number of males and females? 32 males and 28 females are there. And descriptive statistics give us the mean and standard deviation of all the variables in combination with, for example, senior managers, there is 1 for male, 2 for female. The overall mean for males is 2.78 and the mean for females is 2.73. There are 10 males and 10 females and the overall mean of the senior managers is 2.7624 and so on. Now we see Levene's test for equality of variance. You can see that F test is 0.498 and more importantly the significance, the p-value is 0.77, and you know for Levene's test to be successful we should have a p-value more than 0.05. so it shows that our dependent variable groups is divided in the groups and those groups have equal variances. Now we come to the main table. This is called test between subjects effects. This is the main ANOVA table. Actually you have to see first thing, which is the interaction effect. Here you can see position and there is steric gender. This shows a multiplication or combination or the interaction term of position and gender, and from here we see that the p-value is 0.206, which shows that p-value is more than 0.05 and it means that there is no interaction effect in this whole model. But we can see that position is significant, so position has a significant main effect. This is interaction effect, position and gender, and these are two, position and gender separately are two main effects. Position shows that p-value is less than 0.05. It means that position is statistically significant. Now we need to know, now we are quite clear that there is no interaction between gender and position, and we need to understand that where are the differences, because gender is not significant as well, so only significant variable is position. Let us see post hoc test. From this post hoc test we can see that senior managers and middle managers have a significant difference. Whenever there is a significant difference, you can see this is the value of P is 0.031, and significant different groups are shown by asterisk. You can see this asterisk over there, and similarly this table, this particular cell and this particular cell are same. So there are the differences between the stress levels of senior managers and the middle managers, but there are no gender differences over there. So we can conclude from this particular table that these multiple comparison shows that senior and middle managers have different stress levels. Let us see which has higher. Here you can see the stress level of the senior managers stress level is 2.76, while middle managers stress level is 2.81. It shows that the middle managers experience more stress as middle managers experience more stress as compared to the senior managers. And this was our two-way ANOVA or two-way analysis of variance. It shows that we did not have any interaction effect. How would you write the results? Let us see the results. Presenting the results from two-way ANOVA. A two-way between groups analysis of variance was conducted to explore the impact of gender and position on levels of stress. Subjects were divided into three groups according to their position in the organization. Group 1 was senior managers, Group 2 middle managers, and Group 3 junior managers. There was a statistically significant main effect for position, where F with 2 degrees of freedom and 60 and F value 3.259 with P value 0.046. However, the effect size was small, that was 0.108. Post hoc comparison using Tucky HSD test indicated that the mean score of the senior managers was 2.76. It was significantly different from middle managers with mean value 2.81. The main effect of gender and the interaction effect did not reach any statistical significance. I also would like to show you again the output. Please see the output. Here you can see the effect size. This partial eta squared is the effect size for each particular variable. Here the effect size of position is 0.108. This effect size is not shown in other tests, but in two-way analysis of variance it shows. So 0.108 was the effect size, which is according to Cohen's D formula, it is small effect size. So students, I hope you would have understood the two-way analysis of variance. People also call it two-factor analysis of variance. But you can see there is one thing which is very important to note, that there was no interaction effect. In the next video, lecture number 25, I shall be showing you what if there is an interaction, there is a statistically significant interaction between the two categorical independent variables. What happens then? What we have to do? Till the next video, thank you very much. And I hope you have understood two-way analysis of variance. Take care.